So areas of focus here really look at simulations for reliability. So what happens when things fall over, force a failover, see what happens. Define your requirements for your reliability. So don't just build things that are overly reliable that don't need them. But at the same time, don't build something that's can fail, that's going to cause you a huge issue, either from a business point of view or from an infrastructure point of view. We've spoken about scaling horizontally, and then in terms of the failure that will happen, aspirationally here, self-healing systems is something someone talks about. They're quite hard to do. They rely on a lot of automation and a lot of heavy monitoring, but it's certainly something you should be looking towards. Identifying the right architecture for your application, or for your whether that's simply production, active, passive constructs, which we're going to have a look at in a minute. And then identifying roles and responsibilities. When something goes wrong, who needs to be alerted, and who needs to fix the problems that are happening. So on the reliability side of things, so just give the example here again of VMs. A single VM on a premium SSD will give you 99.9 uptime. That equates to about 40 minutes a month in terms of downtime. If that's not acceptable, what are the things that you can do? Well, you can put 2 VMs in an availability set. If you do that, Microsoft will give you an SLA of 99.95. Brings it down to about 20 minutes. An availability set is separate fault domains. So a fault domain is a group of VMs that share a common power source and a network switch. By spreading VMs across fault domains, it limits the impact of that kind of physical hardware failure happening within that fault domain. Taking it one step further, 2 VMs across availability zones. That's basically getting you to the point where you're spanning individual facilities, so data centers effectively. Uptime that is much more improved, and you're looking at a much bigger kind of outage there that you're trying to protect against. And then finally, if you're looking at the entire region, an entire region going down, what problems does that cause you? And again, this is in terms of how you recover from that. You need to understand what's acceptable for as a business. You can look at active passive solutions, which is the ones here, which is looking at that first region using Azure Site Recovery to move services into a second region, and then you'll be able to spin those up and kind of start working. For a lot of sort of web front end internet only kind of services that we see for customers that deploying SaaS services and the like, active is what they'll put in place. So spreading traffic across 2 different regions that are both up at the same time. So from a reliability point of view, what are some of the key things that we need to be looking out for? So driving automation. So still the leading cause of application downtime is usually human error. Minimize the possibility of that through automation, take the human element out of it. Designing for scale out, we want to be successful, we want our applications to be used, looking at the ability to apply horizontal growth to those services and how they will respond. Design for business requirements. Like we said, there's no point putting in 5 nines on a service that isn't critical to the business, because it would be extremely expensive and you won't be able to spend your budget other places. Design for failure. Azure is effectively a highly distributed multi-tenant environment. Things will go wrong and things will fail from time to time. By anticipating those failures from either individual components or losing an entire region, you can develop a solution that works for you and your business. Observe your application health. So before kind of mitigating issues that impact the reliability of your application, you must first detect them. You can't fix things that you can't see. monitoring is absolutely key to that. And then design for self-healing. Like we said, it's it's an advanced concept, relies on a high degree of system maturity, monitoring and automation, but it should certainly be an aspiration for anyone that's running services on any cloud.